Hello, welcome back. It's Sunday today, 4 September. So now I finally got to the Pentium PDF. I'm freezing a little bit. It's not cold, but it being 30 degrees like 5 weeks in my apartment. Now it's only like 24 or something normal. I need to get my fleece jacket on. No, I'm not freeze, but I feel a little bit cold because I only have this t-shirts and bare legs. It's not cold at all, but I'm a little bit tired and I was sneezing and maybe start to get a little bit sick. Yes, it's 29, but I'm freezing a little bit and sneezing. I maybe start to get a little bit sick. But it's 4 p.m., a little bit more, 4 p.m. Let's continue. Pentium 3 and 4, Pentium M, multi-core processors, Pentium D, Pentium dual core. But the camcorder is already, it's low. It's a bit low on power because something wrong with this battery. But this is only 8 pages. I think we can do this. We can do this in one part video. So let's get started.
Pentium 3. Pentium III Intel Pentium 3 processor logo.svg. General information launched February 28, 1999, discontinued April 2004. 4 desktop units, May 18, 2007. 4 mobile units, 1. Common manufacturer, S. Intel. Performance max. CPU clock rate 400 MHz to 1.4 GHz, FSB speeds 100 MHz to 133 ms. Architecture and classification technology node 0.25 M to 0.13 microarchitecture 6 instruction set IA32 MMXSSE physical specifications cores 1 socket S slot 1 socket 370 Socket 495, mobile. The Pentium 3, 2, marketed as Intel Pentium 3 processor, informally PIII-3P, and stylized as Pentium. Brand refers to Intel's 32-bit x86 desktop and mobile CPUs based on the 6th generation 6P microarchitecture introduced on the 28th of February, 1999. The brand's initial processors were very similar to the earlier Pentium 2 branded processors. The most notable differences were the addition of the streaming SIMD extensions, SSE, instruction set, to accelerate floating point and parallel calculations, and the introduction of a controversial serial number embedded in the chip during manufacturing. The Pentium 3 is also a single-core processor. Even after the release of the Pentium 4 in late 2000, the Pentium 3 continued to be produced with new models introduced until early 2003, and were discontinued in April 2004 for desktop units, 3, and May 2007 for mobile units. 1. Contents. Processor cores cadmium I. Coppermine. Coppermine T. Tualatin. Pentium 3's SSE implementation. Core specifications. Controversy about privacy issues. Pentium 3 RNG, random number generator. See also. References. External links. Processor cores. Similarly to the Pentium 2, it superseded The Pentium 3 was also accompanied by the Celeron brand for lower-end versions, and the Xeon for high-end, server and workstation, derivatives. The Pentium 3 was eventually superseded by the Pentium 4, but its 2-18 core also served as the basis for Pentium M CPUs, which used many ideas from the 6P microarchitecture. Subsequently, it was the Pentium M microarchitecture of Pentium M branded CPUs, and not the net burst found in Pentium 4 processors, that formed the basis for Intel's energy-efficient core microarchitecture of CPUs branded Core 2, Pentium Dual Core, Celeron Core, and Xeon. Socket 479, Mobile. Products, models, variants. Core name, S, Katmai, desktop only. Coppermine. Coppermine T, desktop only. 2-18. Variant, S, Celeron. History: predecessor Pentium to successor Pentium 4, desktop, Pentium M, mobile. Intel Pentium 3 processor family. Standard logo, 1999 to 2003, mobile logo, 2001 to 2003. Desktop codename EDCore. Released Pentium 3 logo, 1999 to 2003. Pentium 3M logo, 1999 to 2003. Katmai Coppermine Coppermine 250 nm 180 nm 180 nm 130 nm February 1999 October 1999 June 2001 June 2001 List of Intel Pentium 3 processors. Katmai. A Pentium 3 Katmai SECC2 cartridge with heatsink removed. Katmai die shot. The first Pentium 3 variant was the Katmai, Intel product code 80525. It weighs. A further development of the DISC-Shoots Pentium 2. The Pentium 3 saw an increase of 2 million transistors over the Pentium 2. The differences were the addition of execution units and SSE instruction support, and an improved L1 cache controller. The L2 cache controller was left unchanged, as it would be fully redesigned for Coppermine anyway, which were responsible for or performance improvements over the DISC-Shoots Pentium IIS. It was first released at speeds of 450 and 500 MHz in February 1999. Two more versions were released, 550 MHz on the 17th of May 1999 and 600 MHz on August 2, 1999. On the 27th of September 1999, Intel released the 533B and 600B running at 533 and 600 MHz respectively. The B suffix indicated that it featured a 133 MHz FSB instead of the 100 MHz FSB of prior models. The Katmai contains 9.5 million transistors, not including the 512 kbps L2 cache, which adds 25 million transistors, and has dimensions of 12.3 mm by 10.4 mm, 128 mm 2. It is fabricated in Intel's P856.5 process, a 0.25 micrometer complementary metal oxide semiconductor, CMOS, process with 5 levels of aluminum interconnect. 4. The Katmai used the same slot-based design as the Pentium 2 but with the newer slot 1 single-edge contact cartridge, SECC. 2 that allowed direct CPU core contact with the heatsink. There have been some early models of the Pentium 3 with 450 and 500 Ms packaged in an older SECC cartridge intended for original equipment manufacturers. OEMs. A notable stepping level for enthusiasts was SL35D. This version of Katmai was officially rated for 450 MHz. But often contained cache chips for the 600 MHz model and thus usually can run at 600 MHz. Coppermine. The second version, codenamed Coppermine, Intel product code 80526 was released on the 25th of October 1999, running out 500, 533, 550, 600, 650, 667, 700, and 733 MHz. From December 1999 to May 2000, Intel released Pentium II running at speeds of 750, 800, 850, 866, 900, 933 and 1000 MHz, 1 GHz. Both 100 MHz FSB and 133 MHz FSB models were made. For models that were already available with the same frequency, an E was appended to the model name to indicate cores using the new 0.18 micrometer fabrication process. An additional B was later appended to designate 133 MHz FSB models, resulting in an EB suffix. In overall performance, Coppermine had a small advantage over the advanced micro devices, AMD, Athlons it was released against, which was reversed when AMD applied their own de-shrink and added an on-die L2 cache to the Athlon. Athlon held the advantage in floating point intensive code. A 900 MHz Coppermine FCPG Pentium 3. Coppermine die shot. While the Coppermine could perform better when SSE optimizations were used, but in practical terms there was little difference in how the two chips performed clock for clock. However, AMD were able to clock the Athlon higher, reaching speeds of 1.2 GHz before the launch of the Pentium 4. In performance, Coppermine arguably marked a bigger step than Katmai by introducing an on-chip L2 cache, which Intel names Advanced Transfer Cache, ATC. The ATC operates at the core clock rate and has a capacity of 256 KB, twice that of the on-chip cache formerly on Mendocino Celerons. It is 8-way set associative and is accessed via a double quad word wide 256-bit bus 4 times as wide as Katmai's. Further, latency was dropped to a quarter compared to Katmai. Another marketing term by Intel was advanced system buffering, which encompassed improvements to better take advantage of a 133 MHz system bus. These include 6 fill buffers versus 4 on Katmai, 8 bus queue entries versus 4 on Katmai, and 4 write-back buffers versus 1 on Katmai. 5. Under competitive pressure from the AMD Athlon, Intel reworked the internals, finally removing some well-known pipeline stalls. As a result, applications affected by the stalls ran faster on Coppermine by up to 30%. The Coppermine contained 29 million transistors and was fabricated in a 0.18 micrometer process. The Coppermine was available in 370-pin FCPGA or FCPGA2 for use with socket 370, or in SECC2 for slot 1, all speeds except 900 and 1100. FCPGA and slot 1 Coppermine CPUs have an exposed die. However, most higher frequency SKUs starting with the 866 MHz model were also produced in FCPGA2 variants that feature an integrated heat spreader, IHS. This in itself did not improve thermal conductivity, since it added another layer of metal and thermal paste between the die and the heatsink, but it greatly assisted in holding the heatsink flat against the die. Earlier Coppermines without the IHS made heatsink mounting challenging. 6. If the heatsink was not situated flat against a die, heat transfer efficiency was greatly reduced. Some heatsink manufacturers began providing pads on their products, similar to what AMD did with the Thunderbird Athlon, to ensure that the heatsink was mounted flatly. The enthusiast community went so far as to create shims to assist in maintaining a flat interface. 7. A 1.13 GHz version, S-Spec SL4HH, was released in mid-2000 but famously recalled after a collaboration between Hardock and Tom's Hardware. 8. Discovered various instabilities with the operation of the new CPU speed grade. The Coppermine core was unable to reliably reach the 1.13 GHz speed without various tweaks to the processor's microcode effective cooling, higher voltage, 1.75 V versus 1.65 V, and specifically validated platforms. 8. Intel only officially supported the processor on its own VC820i820 based motherboard, but even this motherboard displayed instability in independent tests of the hardware review sites. In benchmarks that were stable, performance was shown to be subpar, with the 1.13 GHz CPU equaling a 1.0 GHz model. Tom's Hardware attributed this performance deficit to relaxed tuning of the CPU and motherboard to improve stability. 9. Intel needed at least 6 months to resolve the problems using a new CD0 stepping and re-released 1.1 GHz and 1.13 GHz versions in 2001. Microsoft's Xbox game console uses a variant of the Pentium 3/mobile Celeron family in a micro PGA2 form factor. The S-spec designator of the chips is SL5SX, which makes it more similar to the mobile Celeron Coppermine 128 processor. It shares with the Coppermine 128 Celeron its 128 KB L2 cache, and 180 nm process technology, but keeps 8-way cache associativity from the Pentium 3.10, although its codename could give the impression that it used copper interconnects. In reality, its interconnects were aluminium. Coppermine T. This revision is an intermediate step between Coppermine and Tualatin, with support for lower voltage system logic present on the latter but core power within previously defined voltage specs of the former so it could work in older system boards. Intel used the latest FCPGA2 Coppermines with the CD0 stepping and modified them so that they worked with low voltage system bus operation at 1.25 VAGTL as well as normal 1.5 VAGTL plus signal levels, and would auto-detect differential or single-ended clocking. This modification made them compatible to the latest generation Socket 370 boards supporting Tualatin CPUs while maintaining compatibility with older Socket 370 boards. The Coppermine also had two-way symmetrical multiprocessing capabilities, but only in Tualatin boards. They can be distinguished from Tualatin processors by their part numbers, which include the digits 80533. For example, the 1133 MHz SL5QKP/N is RK80533PZ006256, while the 1000 MHz SL5QJP/N is RK80533PZ001256. 11. Tualatin. A 1.13 GHz FCPGA2 Tualatin 256 Intel Pentium 3T. Tualatin die shot the third revision, Tualatin 80530, was a trial for Intel's new 0.13 micrometer process. Tualatin-based Pentium 3s were released during 2001 until early 2002 at speeds of 1.0, 1.13, 1.2, 1.26, 1.33 and 1.4 GHz. A basic shrink of Coppermine. No new features were added, except for added data prefetch logic similar to Pentium 4 and Athlon XP for potentially better use of the L2 cache, although its use compared to Toth's newer CPUs is limited due to the relatively smaller FSB bandwidth. FSB was still kept at 133 MHz. 12. Variants with 256 and 512 KB L2 cache were produced, the latter being dubbed Pentium 3S. This variant was mainly intended for low power consumption servers and also exclusively featured SMP support within the dualating line. Although the socket 370 designation was kept, the use of 1.25 AGTL signaling in place of 1.5